Hello learners, welcome back to my channel Shraddha's Physics. In this part we will see the previous year question of SSB Physics, that is 2021 year. So here we will discuss about the question number 66 to question number 75. So we have already discussed from the question number 1 to 65. Now let us see the question number 66, that is the output of a logic gate is 1 when all its input are at logic 0. The gate is called what? Okay, so here the output of the logic gate is 1. So the output here is 1 when all its inputs are at logic 0. So first of all, when all the inputs are 0 means suppose there are two inputs A and B. If I will let it is 0 and also this one is 0. And for A plus B, if I write for the OR gate, so for the OR gate, that is A plus B, 0 plus 0 is 0. And for the AND gate, A into B means 0 into 0 is also 0. So this is not, it means that I cannot say that the output, the gate will be OR gate or the gate will be AND gate. But here in the question it is given that the output of the logic gate is 1. So when I will place a NOR gate, okay, if I place a NOR gate, that is for the A plus B bar, if I write here A plus B bar, that is the NOR gate of this A plus B, so it will give you 1. And also for the NAND gate, that is suppose AB bar, then it will also give you 1. That is simply I can say that if I will place a NOR gate or if I will add a NOR gate over the output, then I will always get the inverse result. Okay, when the input is 0, I will get the result output to be 1. When the inputs are 1, then I will get the output to be 0. Okay, so the correct answer will be the NOR gate. Okay, now let us see the next question. Indicate which of the following logic gates can be used to realize all the possible combinational logic functions. It means that in the question it is asking that by using which one of the following gate or which of this following gate you can use any of the combination, that is by using NAND gate. By using this NAND gate you can form OR gate, you can form AND gate, you can form NOT gate, you can form XOR gate, you can form XNOR gate, and etc. And similarly by using this NOR gate you can also form the OR gate, AND gate, NOT gate, XNOR gate, XOR gate, etc. So here this NAND gate and the NOR gate, it is called the universal gate because of this reason only, because from this NAND gate and NOR gate you can form any of the logic gate. Okay, that is you have to check, indicate which one of the following logic gates can be used to realize all the possible combinational logic function. Okay, so the NAND gate as well as the NOR gate is the correct answer. Okay, now let us see the next question. The function f of z of a complex variable z is given by f of z equal to 1 by z square plus 1 whole cube, and you have to calculate the residue of the function f of z at the pole z equal to I. So here let me write the question. So here the function is given f of z equal to 1 by z square plus 1 whole cube, and you have to calculate the pole or the you have to calculate the residue of the function f of z at z equal to I. Okay, so this is our question. So now this f of z equal to 1 by z square plus 1 whole cube, it can be written as 1 by z plus I into z minus I whole cube, because you know z, if I put z square plus 1 equal to 0, then that implies z square will be equal to minus 1, and that implies z will be equal to root over of minus 1. This is your root over of minus 1 and its value equal to iota, and this root over means this is your plus or minus I. Okay, so the roots are z plus I into z minus I. These are the roots, because plus and minus I are the roots of this z, so I can write z square plus 1 to be z plus I into z minus I. Okay, let me erase this part. Okay, now here I can write f of z equal to this much, and also you can see here this is the pole of order 3. This is the pole of order 3. And now if I use the formula that is for the nth order, for the nth order pole you can write that is equal to, for nth order pole at z equal to z naught, suppose you can write 1 by n minus 1 whole factorial into d n minus 1th order by dz n minus 1th derivative, d by dz of n minus 1th derivative into f of z into z minus z naught, that is the point given, z minus z naught whole power n. Okay. So now for that, if I will solve this one, that will be 1 by, here the order is 3, that is this value is n equal to 3, that is 1 by n minus 1 factorial, that will be equal to 1 by 3 minus 1 factorial. So that will be equal to 1 by 2 factorial into d square by dz square into, in place of f of z I will write 1 by z plus I into z minus I whole cube into, here the z naught point is given z equal to I. So here this will be z minus I whole power, in place of n I will write 3. Okay. So 1 z minus whole cube and here also z minus 1 whole cube get cancelled, that is equal to 1 by 2 factorial into d square by dz square of 1 by z plus I whole square. And if I will take the derivative of this one, that will be equal to, first of all I will take first derivative, d by dz of 1 by z plus I whole square, that will be minus 2 into 1 by z plus I whole cube. And again this is equal to 1 by 2 factorial into, this minus 2 is taken common, so this is minus 2 into d by dz of 1 by z plus I cube will be equal to minus 3 into 1 by z plus I whole power 4, and here you have to put z equal to I, and again minus 2 into minus 3, that will be, sorry just a minute, this is your z plus I cube. So let me solve it again, this is your d square by dz square 1 by z plus I cube, because after cancelling you can see here in the question this is z plus I, z square plus 1 whole cube. So here this is z plus I into z minus I whole cube. So here after cancelling this z plus I whole cube, and this is equal to 1 by 2 factorial, 1 by 2 factorial. If I will take first derivative, then this will be d by dz of, this will be minus 3 divided by z plus I power 4. Okay. And again if I will take the derivative, then that will be equal to 1 by 2 factorial and minus 3 is taken common, that will be minus 4 divided by z plus iota whole power 5. Okay. And you have to calculate for z equal to I point, and minus 3 into minus 4, that will be equal to 12 divided by 2 factorial into, in place of z if I will put I, so I plus I, that will be 2i, so that is 1 by 2y whole power 5. Okay. And you know I square value is minus 1, so I square into I, that is your I power 5, I square is minus 1 and again minus I square is minus 1, so minus 1 into minus 1 plus 1 into I, so this will be simply I, and 2 power 5, and that is equal to, so finally I can write this is equal to 12 by 2 factorial means 2 into 1 by 2 power 5 is 32 into I. Okay. If I will cancel, this will be 2 6 is 12 and here 2 again 2 3 is 6 and 2 16 is 32. Okay. So that is equal to 3 by 69. Now let me check. Yes, 3 by 69 is given. So here simply this is our correct answer. So you have to remember the formula, that is the residue of the function for the nth derivative. If you have to calculate for the nth order. So for the nth order, 1 by n minus 1 whole factor, d by dz of n minus 1th derivative, f of z into z minus z naught power n. Okay. So now let us see the next question. An RS latch or SR latch is, it is a combinational circuit or synchronous sequential circuit, or one bit memory element or one log delay element. So basically the SR latch is one bit memory element. This is one bit memory element. Now let us see the next question. The Fermi energy is the energy of the electrons. So the options are at the topmost field level at the 0 Kelvin, or at the topmost field level at the room temperature, or at the conduction band at the room temperature, or at the valency band at the room temperature. So here the Fermi energy, it is the energy of the electrons at the topmost field level at the 0 Kelvin. So this is the correct answer. Now let us see the next question. Identify the band gap semiconductor material. So the direct band gap semiconductor material is gallium arsenide. Okay, this is the direct band gap semiconductor material, that is gallium arsenide. Now the next question is, the effective mass of the electron is calculated from, so the effective mass of the electron, you know, it is calculated from energy versus momentum. Now let us see the next question. In superconductors, the Fermi energy level is, so in case of the superconductor, the Fermi energy level, it is the midway between the ground state and the fast excited state. This is only for the superconductor. Okay. Now let us see the next question. The susceptibility of the paramagnetic material is, you know, the susceptibility for the paramagnetic material is chi equal to C by T, or that is, we can say this is positive and small. The next question is, according to the Stefan-Boltzmann law, the radiation density inside a cavity, it is proportional to which power of the temperature? So this is the fourth power of the temperature. Okay. So according to Stefan-Boltzmann law, the radiation density inside the cavity will be proportional to T power 4. The next question is, in the single slit diffraction experiment, the width of the central maximum, it increases with the, so it will increases with the, so you know, from the single slit diffraction experiment, the central maximum, this is equal to 2 lambda d by a, and where this t represents the distance of separation, distance between the source and the slit, source and slit, and here the a represents, this is the separation between the slit, separation of slit. Okay. So here you can see the central maximum, when it will increases, then here this a will decreases, because this is proportional, inversely proportional to a. So here the central, when the central maximum increases, we can say the slit width decreases, or simply by decreasing the slit width, the width of the central maximum increases. Now let us see the next question. This is all for today. In the next part we will see some more questions on it. Okay, thank you all.